Hey again, everyone. This is the third lecture from week 2, and we're going to discuss acceleration with regard to motion in 2 or 3 dimensions. So let me share the screen here. Again, I'm only going to focus on 2 dimensions in this situation, but you could always have a z component as well, right? But for now, let's just focus on 2 dimensions and talk about the definition of instantaneous acceleration. We will also have an average acceleration that I'll talk about in a moment. Now, definition of acceleration is that it is the derivative of the velocity. So a of t is equal to dv dt, or you can write it as the second derivative of the position. Now, let's do an example. So the velocity, again, this is an instantaneous velocity. Let's just say it's 3t I hat minus 5t squared j hat. Now, I haven't put the units, but they would be meters per second typically. So just take the derivative of either component, right? So the derivative of 3t is 3. Derivative of negative 5t squared is negative 10t. And these would have units of meters per second squared, typically in the metric system, right? So this is an acceleration. Now, again, it works exactly the same way as any other vector. You could get the magnitude of the acceleration, you could get the direction or an angle, and each of these components are independent of one another, right? So the acceleration in this situation is staying constant in the x component, but getting faster downward in the y component, in the y direction. Okay, so that's our instantaneous acceleration, and you may see a problem in the homework where you have to take derivatives like this. Let me talk about average acceleration for a moment. And again, it's a little tricky. It can often be confusing when you're looking at the difference between velocity and acceleration. So remember that velocity is how far you've gone in the amount of time you've taken. It's the rate of change of your displacement. Acceleration is the rate of change of your velocity. So if you are not speeding up or slowing down, you're not changing your velocity, there is zero acceleration. It also is interesting that, let's say you were going at a constant speed. Could you still have an acceleration? Well, the answer there is yes, because you could be moving, for example, in a circle. If you are moving in a circular motion at a constant speed, your velocity is always tangent to that circle, but you might be able to keep it constant, right? What I mean by constant is the magnitude is not changing. So maybe you're driving around in a turn at a constant speed of 20 miles per hour. As long as you're keeping that velocity constant, you're going to go in that circular motion. You still have an acceleration, right? You're still accelerating because your velocity is changing direction, right? And this type of acceleration is in fact called a centripetal acceleration. You can see a couple of examples of this taking place in the discussion videos for this week, if you want to take a look at those and ask a question about them in the discussion. We're going to come back more to centripetal acceleration later, but one thing I want to point out here, the instantaneous acceleration is may be changing, right? In fact, it happens that the acceleration, the centripetal acceleration, is always pointing into the circle. So at every point on the circle, every moment of time, the acceleration here has a different direction. But what if I asked, what was my average acceleration between this point and this point? Could you see that it would be 0? Because I am going up with positive v here and negative v here. Now, actually, it wouldn't be 0, would it? Let me kind of write it out in components. So let's say this is my v initial, and this is my v final, and I have a magnitude of velocity, we'll say v. Let's just say it's 10 meters per second. Another word for this magnitude of the velocity vector is the speed, right? So speed is actually a scalar. It's the magnitude of the velocity vector without regard to the direction of that vector. Okay, well, let's get our acceleration now. Now, I'm not taking a derivative here because I'm getting the acceleration between 2 points that are separated by a certain time interval. Okay. Now, if I want the acceleration over that time, I'm going to need to know the time. Well, let's figure that out in a moment. Okay. So my acceleration here is going to be, first of all, v final minus v initial over whatever the time interval is. Now let's write it out. Now, can you see that my final velocity is just negative 10 meters per second downward? That's why my negative sign is there, and it's in the j hat direction. My initial velocity, whoops, this should be minus, so v final minus v initial, which is positive 10 meters per second upward. And then I'm going to divide by my time. Now, we're going to come back to this later, and we'll figure out how the time is related to the velocity or the speed. But for now, let's just say it is a time of 2 seconds. Say it took 2 seconds to go from here to here. Okay, so what I'm going to get is negative 10 minus 10, so negative 20 meters per second over 2 seconds, or negative 10 meters per second squared. So I do have an acceleration, and it's in the j hat direction, right? Because both of these were components here in the x direction, or sorry, the y direction. So I do have an acceleration downward, but this is an average, right? It's the average between this finite time interval. It's not the same as instantaneous. The instantaneous acceleration is going to be maybe different at different points. But my point for this lecture is that you still calculate the acceleration the same way you would for any vector. You take the components of the final velocity and subtract them, or subtract the initial components of the final velocity, or the initial velocity. Right. So when you're doing these type of problems, the vector addition, vector subtraction is always the same, but you have to be careful which components you're using, and be careful when you're talking about average acceleration and instantaneous acceleration. We will come back and talk more about acceleration, position, and velocity when we go on to projectile motion in week 3. Now, just real quick, well, I think we'll stop there for this lecture video. We just have one more thing to talk about in the next video, and that is, what if you had to multiply vectors? So we'll talk about one aspect of that in the next video.